This is OpenNMS 102 again, the MIB compiler. The SNMP MIB compiler is covered in the Horizon Operations documentation in the Deep Dive Horizon Administration SNMP MIB Compiler section. Defining data collection XML file content for tutorial purposes can be simple, especially when dealing with a single object. This is data collection/tutorial.xml from Module 11, Data Collection. Recall, this was a copy and paste, search and replace operation. The simple can become complex. The top snippet is taken from the Cisco MIB file, cisco-association-mib.my. It is a single ASN.1 definition of the C.11 as stats associated object type. There are 80 of these object types defined in that MIB file. The OpenNMS MIB definition of C.as associated is highlighted in the lower snippet. Manually creating a MIB object line from an ASN.1 entry in a MIB file is a complex task for one object type definition, let alone 80 definitions in this particular MIB file, let alone the 200 plus other MIB objects defined in cisco.xml derived from other Cisco MIB files. There has to be an easier way. There is. It is the OpenNMS MIB Compiler. To access the MIB compiler, click on Admin Configuration. Scroll to the bottom of the configuration page and click on SNMP MIB Compiler. The MIB Compiler page is divided into two columns: the MIB Compiler, which separates between compiled and pending MIBs, and the MIB Console. Compiled MIBs are those MIB files that OpenNMS can use to process new MIBs. OpenNMS stores compiled and pending MIBs under /var/OpenNMS/MIBs. The insert reflects the compiled and pending MIBs. There are 9 compiled MIBs and no pending MIBs. This demo is going to compile an external MIB file and create a data collection XML file from that compiled MIB file. An SNMP graph properties file for Cisco-ALPS objects will also be created. The external MIB is cisco-alps-mib.my. ALPS is a tunneling mechanism that transports airline protocol data across a Cisco router-based TCP/IP network to a mainframe. This is the cisco-alps-mib file. At the top of the file, there is an import directive. The from indicate a required MIB. SNMP v2-SNOI is already in OpenNMS. SNMP v2-conf is already in OpenNMS. SNMP v2-tc is already in OpenNMS. if-mib is already in OpenNMS. Cisco-SMI is not in OpenNMS. RFC 1382-MIB is not in OpenNMS. This is the Cisco-SMI file. At the top of the file is an import directive. The from indicate a required MIB. SNMP v2-SMI is already in OpenNMS. This is the RFC 1382-MIB file. At the top of the file is an import directive. The from indicate a required MIB. RFC 1155-SMI is already in OpenNMS. RFC-1212 is already in OpenNMS. RFC 1213 is already in OpenNMS, but RFC-1215 is not in OpenNMS. This is RFC-1215. At the top of the file is an import directive. The from indicate a required MIB. RFC-1213-MIB is already in OpenNMS. Cisco-ALPS-MIB, Cisco-SMI, RFC-1382-MIB, and RFC-1215 need to be compiled into OpenNMS to build a data collection file for Cisco-ALPS-MIB. Return to the MIB compiler and click on Upload MIB. Select this file, cisco-alps-mib.my. The file name appears under Pending. Select the cisco-smi.my file. The file name appears under Pending. Select the file RFC-1382-mib.my. The file name appears under Pending. Select the file RFC-1215.mib. The file name appears under Pending. Right-click on RFC-1215.mib and select Compile MIB. Right-click on RFC-1382-mib.my and select Compile MIB. An error is produced. The error is error, problem found when compiling the MIB. Error, cannot find imported symbol RFC-1382-mib.mib at line 28, position 19, object type in module RFC 1212. Source RFC 1382-MIB.MIB row 28, column 19, object type. The contents of the RFC-1212 MIB are: the file is just a shim to satisfy modules that attempt to import the object type macro from RFC 1212. The object type macro is internally defined by the JSMI parser. Right-click on RFC 1382-MIB.my and select Edit MIB. The problem lines are fairly obvious. Comment out the 2 lines as indicated. Save the changes. Right-click on RFC 1382-MIB.my and select Compile MIB. The compilation works. Before continuing with the compilation, note the /var/OpenNMS/MIBs tree. RFC-1212.MIB and RFC 1382-MIB.MIB are both under Compiled, and Cisco-ALPS-MIB.my and Cisco-SMI.my are under Pending. Right-click on Cisco-SMI.my and select Compile MIB. Right-click on Cisco-ALPS-MIB.my and select Compile MIB. Cisco-ALPS-MIB, Cisco-SMI, RFC 1382-MIB, and RFC-1215 have been compiled. Clear the MIB console. Right-click on Cisco-ALPS-MIB and select Create Data Collection. Change the data collection group name to Cisco-ALPS, all uppercase. The first tab lists the resource groups created. The second tab lists the MIB groups created. The final tab lists the system definitions created. None were created. A system OID or system OID mask is required to create a system definition. This is not necessary to create a data collection XML file. Save the collection file and click Yes to create the default graph templates. Take a brief look at the data collection and SNMP graph configuration files generated by the MIB compiler. Switch to the console and change directory to /opt/OpenNMS/etc/data collection. List the files by creation time. Cisco-ALPS.xml was just created. Change the name to lowercase. Edit the file. The group name is Cisco-ALPS, all uppercase. Change that to Cisco-ALPS, where Cisco is just capitalized. Scroll through the file. Resource types, object groups, and MIB objects were created. All the OIDs begin with .1.3.6.1.4.1.9.9.95. This will be the sysoid mask for a system def. Go to the bottom of the file. Insert a system def named ALPS. The sysoid mask is .1.3.6.1.4.1.9.9.95. The included groups are those that had a good number of numeric values, integers, and counters in the group. Save the file. Recheck the data collection group name. Save and close the file. Change directory to /opt/OpenNMS/etc. Edit the file datacollection-config.xml. Add Cisco-ALPS to the list of included collections. Save and close the file. Change directory to SNMP-graph.properties.d. List the files by creation time. Cisco-ALPS-MIB-graph.properties was just created. Rename the file Cisco-ALPS-graph.properties, all in lowercase. Edit Cisco-ALPS-graph.properties. OpenNMS, through the MIB compiler mechanism, created a graph for every single integer, counter, time ticks, and gauge object in the MIB file. Close the file. The MIB compiler does a decent job on creating the data collection resource types, object groups, and MIB objects. The SNMP graph properties files will contain one report for each numeric object. Get the engineers or admins of the particular device in question to help with the system defs and graph definitions. The MIB compiler can also generate an event definition file from the MIB. The MIB must contain at least one notification type or trap type. The option is available to compiled MIBs only. These are the notification types in the Cisco-ALPS MIB. check for their presence in the MIB Compiler produced event file. Based on naming conventions used in some of the current Cisco event files, the Cisco-ALPS events will be stored in a file named cisco.ALPS.events.xml, and the event template will be uei.openNMS.org/vendor/cisco/alps/traps. From the OpenNMS MIB Compiler page, right-click the Cisco-ALPS MIB object and select Generate Events. The base UEI is uei.openNMS.org/vendor/cisco/alps/traps. Continue and save events file. Return to the console and directory /opt/OpenNMS/etc/events. List the files according to create time. Rename cisco-alps-MIB.events.xml to cisco.alps.events.xml. Do not forget to change the entry in /opt/OpenNMS/etc/eventconf.xml. Edit eventconf.xml and replace the MIB compiler generated Cisco-ALPS file name with cisco.alps.events.xml. Save and close the file. Reload the event daemon. Edit the file to just look things over. Verify the events in cisco.alps.events.xml with the notification types in the MIB. There is a match. The OpenNMS MIB Compiler can create data collection XML files, SNMP graph properties files, and event XML files. With rare exception, all of the created files will need some modifications. The data collection XML file will need system definitions. The SNMP graph property files will need to have some of the metrics combined into a single graph, and the event file will probably need alert data elements. Notifications may have to be attached to some of the events. Still, OpenNMS has provided an excellent mechanism to add new metrics to its collection, storage, display, and notification capabilities.